Our subject of today is the happy molecule. So what does a molecule need to be happy, meaning being rather unreactive, being satisfied? So first of all, it should be neutral in charge. It means no electron excess and no electron deficit if we count the numbers of protons in the atomic nuclei, then it should be the same as the sum of all electrons. So this is the case, for instance, for methane, the CH4 molecule, but it's not the case of the methyl-anion. It has an electron excess, and also not the case for the methyl-cation. It has an electron deficit. Both that methyl-anion and the methyl-cation are highly reactive. Secondly, all atoms of that molecule have to have noble gas configuration. That means that for elements of the first period, while this is hydrogen and helium, noble gas configuration means we have 2 electrons in the outer shell. Well, let's have a look at the hydrogens. Each hydrogen atom is in contact to 2 electrons from that CH bond, and therefore hydrogen here is satisfied. It has contact to 2 electrons. That means it has noble gas configuration. For elements of a second period, they want to have the electron configuration of neon. This means 4 electron pairs in the outer shell. Well, for carbon here in methane, this is the case. We have 4 CH bonds. That means the carbon is in contact to 8 electrons, and this is neon configuration. On the other hand, here for the methyl radical, there is the carbon in contact to 7 electrons, not enough for noble gas configuration, therefore this is highly reactive. Third point, bonds should be neither strained nor restricted from vibration. So here we have a case of strained bonds in the cyclopropane molecule. The electron density is located somewhat outside the direct connection between those carbons. Here we have relatively high electron density, and we say these are banana bonds because, well, they are both like that, and therefore the cyclopropane is highly reactive if it gets into contact to a lot of reagents. Here a molecule is drawn that has been tried to synthesize several times. All attempts failed. Why is this the case? Well, we have an olefin moiety here in the center, and there are sitting 4 very big substituents. They are rather large, and if they try to vibrate, they hinder each other. So they would avoid being close to each other, and this leads to a breakage of that central double bond. Therefore, this molecule does not exist. On the other hand, here in the methane molecule, a happy molecule, all hydrogens are at maximum distance from each other. All CH bond are able to vibrate. On the other hand, you might argue, well, it's not that unreactive if we put it together with oxygen and just one sparkle and it could explode. Yeah, well, but in that case, the oxygen is the unhappy molecule that brings the high reactivity into that system. Thanks for listening.